Hello everyone. As you saw in the gear mechanism animation at the start of this video, you will be able to create the exact same result right after this tutorial. The gear mate is a specific tool in Solidworks used to simulate motion between different type of gears. First we will open the assembly module. Currently we don't have any part or assembly loaded. A quick explanation before we begin. If you already have a part to mount the gear on, like a shaft or a hub or any circular component, you don't need extra references. However, today we are building our references from ground zero. For any rotating component, we need an axis reference. To create one, go to reference geometry and select the axis option. In the menu on the left, select the right plane and the top plane. A yellow axis will appear at intersection of both planes. Click OK. As axis 1 is created, we can see it in also feature tree. Now we will insert a gear from the toolbox. Click on Design Library tab and then click on Toolbox. If it isn't added yet, click Add in now. We will use the ISO standard. Navigate to Power Transmission, then click on Gears. There are several types of gears here. We will work with spur gear. Select it, drag it into the workspace and drop it. On the left, the property manager will open with the specific options. Let's add them. Module to 1.5, number of teeth 50, face width 30, hub style type B or type C. Click OK. We will see another gear attached to your mouse. Simply click anywhere in the workspace to add it. Press escape to close the tool. Now we have two gears. If axis 1 is hidden, click the eye icon and activate view axis to make it visible. By default, the first component is fixed. In our case, the gear is also fixed and cannot move. To make it movable, right click the gear and select float. First we will make it concentric. Click the inner face of gear, hold Ctrl and select the axis. Release Ctrl button and select the concentric mate from the pop-up toolbar. You can also apply this to the standard mate option. Currently, the gear can still move linearly along the x-axis. To restrict this, select the gear face, hold Ctrl and select the front plane. Choose the coincident option. Now it will only rotate about the axis. Now we need a second axis for gear 2. So to calculate the center distance between the two axes, go to the feature tree, expand the first gear folder and find the tooth cut feature. Click the show icon, and if the sketch isn't visible in the second gear, repeat the same procedure for the second one. These circles represent the PCD pitch circle diameter. If we click on the circle, we will see the PCD is 75. Since both gears are the same, the second PCD is also 75 mm. The formula for the center distance is PCD1 plus PCD2 divides by 2. In our case, 75 plus 75 divides by 2 gives 75. So the center distance between both the gear will be 75 mm. We will create the second axis exactly at 75 mm from the first. Go to the reference geometry, click on plane, select the right plane and enter 75 mm in offset distance box. Use flip offset if needed, then click OK. To create the axis, go to reference geometry, axis and select plane 1 and top plane. Once axis to appear, it will appear on the intersection of plane 1 and the top plane. Click OK. Now mate the second gear to the axis using a concentric mate on the inner face and coincident mate on the hub faces. As we can see, both PCD are now tangent, confirming our center distance is correct. Manually rotate the gear so the teeth are perfectly aligned and touching. Now go to the mates, open the mechanical mate menu and select gear. Select the PCD pitch circle of both gear one by one. The diameters will be detected automatically. Click OK. Manually rotate the gear to test the motion. If they rotate in the wrong direction, go back into the mate setting and check the reverse box. Now let's create the animation. Click on motion study at the bottom, select the motor icon. In the blue selection box, select the inner face of gear. You could also select the hub An arrow will show the rotation direction. You can use the reverse direction button if needed to change the direction. So we will left it at the clockwise direction. Set the speed to 10 rpm. Left this constant speed option as usual. Click OK. So keys are now created in the motion manager. To clean up the view, click this I button to hide all axes, planes and sketches. To set up the camera, drag the timeline back to 0 second. Right click on the orientation and camera view and ensure disable view creation is unchecked. Orient the model to your desired view. Then recheck the disable view creation to lock it. Click play to test the movement. To export it, click save animation. At first, provide a file name and select the MP4 file as a file type. Under image size, uncheck fixed aspect ratio and set the size to 1920 and to 1080, the standard landscape option. Set your frame per second FPS to 30 or 60, as now we put 30. Click save. As you can see, processing started. Once the processing is complete, you will hear a notification sound. Let me look on the final result of the video. As we can see, we have now created a perfectly mated gear animation. If you want a tutorial on the more complex gear train shown at the start of the video, comment below. If this video added value to your learning, please like video, share video and subscribe to Mech Motion.